Okay, I'm
All
sorry.
right, so what I'm going to talk about today is, I don't know if somebody has a book in front of them. I need you to look in, I think it's 3.3 or 3.4. I can't remember, but it's called the Empirical Rule. And if somebody could look that up and tell me what page it's on, I'd appreciate it. But I'm going to go to my handy dandy. Let me get this off of here. And there is my document cam. And I'm going to show you something that I go ahead and I tell y'all to do. From here on out, you might want to get one of these printed for you. Now, I know that 95% of y'all are not going to do this, so I'm only talking to the 5% that's going to do it. You need to go to Google and type in normal curve empirical rule. And the reason you need to type in normal curve empirical rule is because it'll give you the one that I use, which is this one right here.
I got that page number for you.
Okay, what page is it?
132.
Okay, page 132. That's where this is coming from. So all of this material that I'm covering today is coming from page 132. Write that down. And what section is that? 3.3? I saw that, Miss Yoakum. I'm going to have to throw you out of class. You yawned. Okay?
It looks like 3.4.
Yeah, look at the top of the page, or it should be at the very top of the page, 3.4. If that's what you say, that's good. All right. Now, I realize that I may be skipping around a little bit, but I promise you, before we get to the z-scores, everything's going to fall into place. Okay?
Hubert.
Z-scores. Yes, ma'am.
Excuse me. I think that it's not. I think you want to know what section it is.
Yeah, it's on page 132.
Yeah, but that's section 3.2.
Yeah, 3.2. Okay, thank you, Miss Dennis. 3.2, page 132. Now, what is this curve? This is the normal curve. All right. Now, what do you do with the normal curve? Number one, what do you do with the normal? Oh, for those of you that don't know what to do, you right click on this, save image, and save it. I saved it as normal something. I can't remember what I saved it as. And save it, and then go pull up a Word document and put it on the Word document and print out 5 or 10 copies, or print out 1 copy, run 25 copies on the Xerox machine, whatever you want to do. Okay, it's real hard. I think it takes about 5 buttons. You've got to push like 5 buttons, and you got to hit print. So for the 2 students that are going to do this, I appreciate it. It'll help you out, because we're going to be doing this. This is 120. We're going to be doing this. You're going to be drawing this curve. Tell them, Miss Dennis, you've seen this class before. You audited this class before. We draw these things over and over and over. Okay?
Yep. I'm going to
print. I'm just telling you. You know, I'm just telling you. All right.
I'm going to draw it over and over again.
Yeah, exactly. So the case being, I'm going to go to there we go. And I'm going to show you the first thing that you need to learn about the normal curve. And that is the bottom. What about the bottom, Hubert? The bottom is filled out by the mean. And then you add the standard deviations on the right, and you subtract the standard deviations on the left. So I'm going to pick a mean. I did a problem over here, and we're going to do it today if I get time. My mean is 18, and my standard deviation is 4. Now I'm rounding because I don't want to have to deal with decimals while I'm trying to show you this. So just ignore the decimals, and standard deviation of 4. So somebody tell me what 18 plus 4 is.
22.
And what's 22 plus 4?
26.
And 26 plus 4?
30.
And 8 minus 4.
Pardon?
18 minus 4.
14.
And 14 minus 4. And 10 minus 4.
There.
Now, that's the first thing that you need to learn about the normal curve. The bottom of it is filled out by the mean, and you add the standard deviation on the right, and you subtract the standard deviation on the left. Now, that's not hard, but I don't know why I have people, when I show this to them, they go, well, how'd you get to 22 and how'd you get to 14? Well, I just told you.
Ask you how you get to 18.
The 18 is, yeah, they do ask that too. That comes from right there. There's the mean right there. Okay?
Oh, okay. Okay.
Now, I rounded up. This is a problem I did for the 103 class, and we're going to do it today if I get time, because I'm going to introduce to y'all the 5-number summary, which we're going to discuss here in a minute. Now, remember, I do realize that this is a lot of information, but what's going to happen is after I cover the mean, median, mode, range, mid-range, variance, standard deviation, and the 5-number summary, we're going to do probably 5 or 6 problems together. Okay, so we're going to go over everything in plenty of time for the test. I promise you. All right, so the first thing is that. The second thing is the empirical rule. So the first thing is mean and standard deviation. Sorry. Mean and standard deviation. Where to put it. And it's at the bottom. The second thing is the empirical rule. The empirical rule is on page 132. And it's on this doojicker right here. The empirical rule says that within 2 standard deviations, I'm trying to find, well, where the heck, there it is. Within 2 standard deviations is 95% of the population. Can somebody tell me what is significant about the 95% population? Those people are considered to be what? Anybody? Anybody remember it from high school? 95% of the population will fall between 2 standard deviations, and those are considered to be what?
Don't talk about high school, Mr. Hubert.
Okay, it's been what, 1,000 years?
Yes, 2000.
Yeah, everybody that didn't graduate high school, it's been 1,000 years.
No, I graduated 1,000 years.
What?
I did graduate, but it was 1,000 years ago during Fred Flintstone.
Yeah, you had a car that had the rocks on it. Yeah. All right. So anyway, those are considered to be normal. 95%. If 100 people fall out of a plane with parachutes, 95% are going to fall within a certain part. That's what this is saying. Also, this is what they like to call it, not unusual. Don't ask me why. Okay? Not unusual. And I don't even know if I spelled that right, but y'all can spell it right. Not unusual. That is 95% of the population. All right, now write that down because I'm going through the empirical rule with you so that way you understand. And the empirical rule, the normal curve, the standard deviation, the 5-number summary, that's all test. These are all test questions that I'm going to test you on. Okay, let's take another marker. Let's take an orange marker. And let's mark this 2.35%. Does anybody remember from high school that took this class? Okay. Does anybody know what that's called? Well, I'll give you a hint. It's the opposite of not unusual.
It is unusual.
Yep. These are all test questions I'm going over. Somebody might put, out of the classroom, this person is 5 years old or 7 years old. Is that unusual? And you would say yes. Because 7 years old is right here. And there. For some reason, I froze up. My finger froze. All right, so what about pink? Now, if the orange, and I want you to listen here. If the orange is unusual, then somebody tell me what the pink is.
Highly improbable.
Okay, yes, but this is one word. I get to use my neon pink Sharpie. See?
Never mind.
What?
I had an idea, but you said it was one word, so.
One word. Starts with an O.
Outliers.
Good job.
Yeah, okay.
And I don't know if it's spelled with an E or an A. I think it's an E. Y'all have to look it up. What's an outlier? Michael Jordan's, your Tiger Woods, your Tom Brady's. Okay, the reason I use those is because those are three people that's considered, greatest of all time. All right. Those are, outliers. Your 6 foot second grader is an outlier. How many of you could play Beethoven's Fifth in the second grade? You are considered an outlier. All right. Anything that's out of the unusual is an outlier. When you take your baby, I don't know if somebody has a baby, but you take your baby to the pediatrician or whatever it's called when they're a baby, they weigh them and they measure their head. Why do they do that? And they measure their height. Why do they do that? Miss Dennis can answer that question. She's not even listening. She's talking.
You do it because
I should throw her out of class, shouldn't I? That's what I should do. Look at her.
Right.
She's listening now.
you measure their head and their height because it determines how much they're going to grow later. You can tell by what it is then how much.
Yes, it puts them in the percentile. Yes. If you measure their head and they got a big old head and they got a small body, then the doctor's going to say, okay, something may be wrong here. Okay. Like I got a friend and I kid him all the time. He had a big old head. And I tell him he had a big old head when he was small, like when he was a baby. That would be out of the 95 percentile, 95th. Everything's based on the 95th percentile when you're measuring a baby, when you're weighing a baby, when you're seeing if you got a big old head or not. Everything is measured on this 95th percentile. So that's why you hear 95th percentile whenever you're talking about a baby. Okay? Because you want to look out. The doctor wants to look out for all the bad stuff that could happen if they have a big old head, or if one, if you take him back after 3 or 4 months and he hasn't grown height-wise, there's something wrong. All right. So that's why we have that. That's the empirical rule. So we just went over the empirical rule. Now what? Well, now we're going to go over the 5-number summary. Now, the 5-number summary is basically for your data. 5-number summary. Basically is for your numbers right here. 95% of the time, you're going to find your 5-number summary in these numbers right here. Okay, but I like to show students what the 5-number summary represents. So what I tell students is and this is just graphically, think of this as your fuel gauge in your car. And this is where the needle is. Somebody tell me what I have right here on the fuel gauge.
Empty.
Good job. And empty represents basically 0%. Okay? Well, what's this right here? If I got a mark right there and my needle is right there, what does that represent?
A quarter.
Quarter. And that's called the first quartile or the 25th percentile. Now we're getting into a lot of standardized test questions. Those of you that need to take the T's, you're going to be asked about this stuff. All right. Now this one's easy. On your fuel gauge, what does that represent?
Half a tank.
So that's the second quartile. Or the 50th percentile. It's also the median. In the 5-number summary, it's the median. And it's also what you said, half a tank. And this is a quarter. And this is 3/4, which is called the third percentile, or third quartile, sorry. And the 75th percentile. And over here is 100% and full. Now, you're not going to be asked on a test to do this on your bell curve. The reason I show you this is because this is what I come up with as a teacher. If I show you this graphically, then when I go to the data, you'll know what you're finding. So here is 0. That's the first quartile or 25th percentile. That's the 50th, the second quartile or the 25th percentile. Now, I know it says mean down here, but if your data is close, what is the mean and the median to each other? They're very close. Your camera went out, Miss Dennis. Just letting you know, something wrong? Let me know if you're still there. I think something happened to Miss Dennis. I don't know where she is. Miss Dennis, are you still there? Anybody see her name anywhere? I'm going to call her back. I don't want to lose Miss Dennis. All right, she's one of the people that talk to me in class. I don't like to lose people that talk to you. You know, those of you that are weaned on a pickle, y'all need to get personality. All right, so here we go. That is the summary. Now, if I go to the data, where is the 5-number summary? Well, I'm going to show you. And I hope Miss Dennis makes it back. She might have been cut off. She might have had to go work or something. Let me see if she come back. Okay, still calling her, so I don't know if she's having technical problems or not. All right, so the median is going to be your second quartile. So make a note of that. You don't have to calculate it because you already calculated it. The mean, now that's real simple. That's this guy right here. So we're going to color that. She's texting me. Hold on. And you fill in the max. I just tried to call her, so I don't know. Something happened. I know that, Miss Dennis. I tried to call you back in. Let me try to call her back in. Okay, now she's talking about the Russians taking over the building. Okay, try calling trying to call you back in twice. Okay, at least she knows I'm trying.
Can I watch the rest of this later? Because I have to go to
Sure.
the Anderson campus.
You go right ahead. Anytime you need to go, you don't need to ask, Mr. Winton. You go right ahead, okay?
All right, thank you.
Next time, you might want to go to the Anderson campus and sit in the lobby or something. But hopefully Monday, we'll meet at the Anderson campus, I hope. All right, see you. There's Miss Dennis. We talked about you while you were gone. Okay. So, I made fun of you. They laughed. All right, so the median is right here. Now we're, Miss Dennis, we didn't do anything except for finish the curve. We finished this. You know, I don't know how far you made it, but we finished that and just talked about it, you know, going like that. And that's not going to be tested. The 5-number summary is going to be tested like here. Okay? So, what is the max? Somebody tell me what the max is. The max is
25.
I tell you what, y'all are just on the ball. I'm so proud of y'all. There you go. So 25, I'm going to highlight that. Miss Dennis, what's your favorite color, Miss Dennis?
White.
White. Come on now, give me a favorite color. Black and white are not colors.
Red.
Red. So I've already got red. I've already got red right there. You got to pick another color. Oh, Miss Luss. Oh, darn. Miss Luss came in and went out. Dang. All right, give me a color.
Orange.
White.
She said orange. There. Now, if you can't get those 3 numbers on the 5-number summary, I'm going to literally throw you out of the class. Why? Because that one is right there. That one is right there. And that one is right there in the middle. You should be able to get those 3 numbers. All right. Now, how many numbers, tell me this. Now, this is how you find the first quartile. How many numbers are above 17 right there? 1, 2, 3, 4, 5, 6. How do I find the median of 6 numbers? 6 is even. How do I find the median of 6 numbers that are even? How do I
You
find the
find the
median?
average of the middle two.
There you go. So I'm going to highlight these 2. 1, 2, 1, 2. I've got the 2 middle numbers right here. I'm going to color those blue. And that, the average of those 2 numbers are going to go with my first quartile. I want you, right now, to average those 2 numbers up and see if you don't get 14.5. And I want you to do the same thing on the bottom. And I do realize, I got a degree and everything, I do realize that 21 and 21, if you average them together, you're going to get 21. I understand that. But if they're 2 different numbers, you have to go through and you have to add them together and divide by 2. And that is the 5-number summary. So let me go over it one more time. The min is the min. The max is the max. The second quartile is the median. And you put your finger on the median right there and count how many numbers are above it. 1, 2, 3, 4, 5, 6. 6 is even. To find the median of 6 numbers, you find the 2 middle numbers and you average them together. That's that. How many numbers are below 17? 1, 2, 3, 4, 5, 6. 6 is even. You've averaged the two middle numbers, and that's that right there. That is how you find the 5-number summary. Now, what does the 5-number summary give you? It gives you the box plot. Now, the box plot is real simple. There's two parts to the box plot. Has two parts. Number one is the number line. That's the first part. And the number line is made up of the mean, the midpoint or the mid-range, and the max. So I'm going to go ahead and draw that right now. So the mean is 12 and the max is 25. The mean is 12 and the max is 25. The mid-range is 18.5. Now you can put 19 if you want to, or if you're a detailed person, OCD, then put 18.5. Okay? I'm going to put 19 because I don't want to have to go through all those decimals. All right. 12 to 19 is 7. Half of 7 is 3. So that's 15. I'm graduating my number line. I'm just putting marks on it. There's nothing spectacular. You just find the midpoint of the midpoint of the midpoint. 19 plus 25 is 44. Half of 44 is 22. And 12 to 15 is 3. Half of 3 is 1.5. So that's going to be 13.5. 15 to 19 is 4. Half of 4 is 2. So that'll be 17. It's very informal. You're just marking up your number line. Half of half of half. That's all you're doing. 19 to 22 is 3 or 4. Half of 4 is 2. That's 21. 22 to 25 is 3. Half of 3 is 1.5. So that's 23.5. And I carry it to about, I do it till you get a good graduation. That's up to you how you want to do that. But it consists, I'm going to do this again, and I don't mean to be repetitive. There's the mid-range. There's the mean. And the max. Now remember, that's the first part on the box plot. And it's the easiest part because you're not really doing anything interpretive. All you're doing is taking a line and making it into a number line. The second part is draw your box plot. Box plot is made up of the first quartile, the second quartile, and the third quartile. And you can draw it on the number line or you can draw it above the number line. I don't really care. So let's write down the three numbers that we need. The three numbers are 15, 17, and 21. 15, 17, and 21. Now, let me go ahead and tell you this. If you're dealing with decimals, you have to carry the decimals, okay? Write that down. I'm not carrying the decimals because I don't want to take up class time running the calculator. And if I ask y'all to do it, y'all going to give me the wrong answers because y'all want to set me up. So I don't ask the class for answers or calculations because of that. All right, so here's my So I take my numbers and I round them up so I don't have to use a calculator while I'm teaching. So 15, 17, and 21. You would actually use that. You would put 14.5 right here if they ask you for the first quartile. Okay, always use your decimals unless you're teaching and then you just round up. All right, so there's my first quartile. So I'm going to put this back up so you can see it. And I'm going to color that. I'm going to circle that one in blue. And I'm going to put 15 right there. And I'm going to pick a light green, and that'll be my 21. And that's going to be right there. And of course, since I highlighted the median yellow, I'm going to draw the yellow mark 17 right here. And there is my box. I'm just going to join the bottoms. There's your box plot. Somebody tell me where the center is. Not like church center, not S-I-N-N-E-R. Where is the center? The mid-range, right? Does somebody tell me what this looks like? Well, the curve looks like this. Because that mean, that yellow mark is right here, is to the left of center. Because remember, everything revolves around the center in statistics. Now we're going to talk about the fourth thing that we're going to talk about today. And I'm going to pull this, hold on just a second. The fourth thing we're going to talk about today is distributions. Okay? And I'm just going to go to the next page here, and I'm going to show you the 4 distributions. And that will revert back to this red line back here. So just bear with me. So, what are the 4 distributions? These are test questions. Everything I'm covering today is test questions because chapter 3 is how much percent of your test? 80% of the unit 1 test. So, okay. So here is your 4 test questions that have to do with distribution. And this is exactly how they'll look on the test. They'll show you a graph representation that looks like this. And it's a rectangle. That's called uniform distribution. Can somebody tell me where we would have uniform distribution where nothing moves? Nothing moves. In other words, there's no variation. It's very constant and nothing you can do changes it. Anybody? What's something that we have not screwed up yet? And something that we cannot screw up as far as mankind? What's the only thing that we cannot control? Okay, y'all suck. Time. Although there are some females that try to manipulate time. If you ever have been to a cheerleading competition or a dance recital, which I have been to both, there are some moms or some women that try to wear their daughter's clothes, and it's not pretty. Okay? So there are some women that try to manipulate time. Not everybody can be Sandra Bullock, okay? There's only 1% of the population of females that can pull that off. So don't try, okay? Uniform distribution. Again, I'm talking about trying to fit in your daughter's clothes. Are you with me? Okay. It doesn't work. All right. So uniform distribution is time. Everybody understand that? Why is it time? Why is it uniform? Because it's about the only thing left that man has not tried to manipulate or screw up. I bet y'all never thought about that, have you? Okay, y'all not going to talk to me? That's fine.
Mind blown, man.
You're still thinking about the moms trying to fit into the teenagers. Okay, let me tell you, who said that? Who said mind blown? Who said that?
I did.
Is that Mr. Michelle?
Yes, sir.
Mr. Michelle, are you married?
No, sir.
Okay. When you get married, you're going to go to a dance recital. I mean, when you have kids and you have a little girl or a little boy, whichever, because they like to do cheerleading. Or, I'm not going to say, dance recital. Yeah, they could be. I remember going to my daughter's dance recitals. There were several boys dancing, and that's a good thing. Dancing is a great thing, okay? But the moms trying to dress in their daughter's clothes and trying to look like they're 18 again, that you'll see it, Mr. Michelle. You're going to see it because you're going to be forced to go to those recitals, okay? I'm just going to go ahead and tell you.
Lord,
Right?
help me to till then.
Okay, well, just remember, I'll be dead and gone probably, but you will be at that dance recital, and I'm going to be up there laughing at you because you're going to be forced to sit through it. All right, so center. I'm kidding. I probably won't be dead, but might be. Hopefully for you, if you wait that long to get married, that'll be a good thing. All right, remember, in statistics, we all put everything or compare everything to the center. So this is normal distribution. Normal distribution, usually think of grades in a class. That's an example. Ages in a class, the average age. Can anybody that's had probability and statistics before tell me what these next two are? All the data is on the left, and all the data is on the right.
Skewed left and skewed right.
Okay, this one is skewed left. It's always the opposite. And this one is skewed right. Now, why did I put those in red? Because they're always the opposite. If all your data is on the left, it's skewed right. If all the data is on the right, it's skewed left. Actually, they go with the tail. This right here is the tail. If the tail is on the right, it's skewed right. If the tail is on the left, think of a snake, it's skewed left. However you want to remember it, I don't really care. Okay? All I care about is that you understand that the data is over here. You may have a couple of pieces over here, but the data predominantly. Now, let's talk about grades. What does this mean if your class looks like this? What does it mean? Come on, people. The center is like the class average. So what does this mean?
They did very poorly.
Okay, everybody sucks. The teacher sucks. The test sucks. The students suck. Okay? That's a bad class. Because everybody is what? Failing. Now, of course, you got your people down here. One thing you're gonna realize in all your college career, there's always one. There's either always one that screws it up or always one that makes 100. There's always one. That is a natural thing in life. There's always one. What about this class? What does this class mean?
They're a good class.
Great class. Either the teacher is great, the class is great, or the tests reflect what you studied. More teachers could be like this if they'd leave their ego and pride at the door. But since they've come, I'm holier than thou, that's what you get with a lot of holier than thou teachers. Okay. Now, I think personally, let's see, class starts at 10:10, so I got 5 minutes. So all I'm going to do, I'm not going to do anything more except for talk about where you should be right now. Right now, everybody, chapter 1 should be done. Chapter 1, you should have that done. 1.1 through 1.4 should be done. Chapter 2, that's 2.1 and 2.2. That's 2.2 is where you do the little bit of math. And 2.3 is reading. That should be done. So right now, everybody's working on chapter 3. And that's 3.1, 3.2. Is it 3.4 and 3.5? Somebody help me out.
Yes, sir.
All right. Right now, you should have enough. You should be working on this homework for Friday. Everybody should be working on 3. I did a little bit of 3.4 with the empirical rule. I meant the empirical rule. I think that's in 3.4 or I can't remember. But the only thing left is z-scores. But I'm not going to cover z-scores until we work this problem right here. We're going to do a couple more of these problems right here with everything. Mean, median, mode, range, mid-range, variance, standard deviation, and the 5-number summary. So we still got a couple of more of these problems to do before we move to z-scores. But what's after z-scores, people?
Test.
Go ahead and say it.
Test.
Test. That means I'm going to pull up a test in class, no time soon. I still got to do a couple of these problems. When I pull up that test, that's when I'm going to assign dates on the test and the homework. Now, there's 2 or 3 of y'all. I don't know what y'all are waiting on. Y'all haven't done any homework whatsoever. I know what you're waiting on. What are you waiting on? You're waiting on that date because you're going to wait and try to do everything the night before that date. And it's not going to work out very good for you at all. Okay? So I'm just going to go ahead and tell you that because that's when the computer blows up and MyLabs Plus is not going to work and the dog's going to eat your keyboard and all that stuff. Any questions? Okay, you're good to go. You can leave when you want to, and I will see y'all Friday. And we'll go over some more of these problems mathematically.
Have a good one.
Y'all do the same. Be good. Be careful. And I'll see y'all.
You too. Have a
Bye-bye.
good week.
You do the same. See you Friday.